Hello to all my friends. Today I want to discuss something which is quite very important for all the researchers, especially the beginners, to understand because in statistics, whenever we are concerned about the relationship of variables, the relationship between independent and dependent variables, we come across a very eminent term which is known as regression. So I am going to discuss with you what is the meaning of regression. Simply, I will explain what is regression, how does it work, what is the fundamental or the principle behind regression, three important assumptions of regression: linearity, endogeneity, and heterogeneity, which need to be tested even if you are working with a model in advanced softwares like smartpls, Danco, or GSCA. It's not that you are working with partial least squares structural equation modeling that you don't need to test in for these assumptions before checking your measurement model or structural model evaluation. So, let us start. What is meant by regression? So, if I say that I want to check on the relationship between two variables, that is x and y, x being my independent variable and y being my dependent variable, right? Say for an instance, the number of study hours being put by a student leads to higher marks in the test. So if I say x is number of study hours being put by the student and y is the marks scored in the test. So is there any relation between how many hours a student spends studying and the marks secured by that student? This relationship we try to find out through regression. In case we have a single independent and a single dependent variable, we call it a binary linear regression or a simple linear regression. In case we have more than one independent variables, we call it multiple regression. In case we have more than one independent and more than one dependent variable, we call it multivariate regression. So this is how we define regression. Now, what happens in this case? So let me show you how this works. So say for an instance, this is a graph where x axis and y axis, x is the horizontal axis which depicts the study hours being put by the student, and y is the marks secured in the test. So regression equation, you must have come across y is equal to a plus b multiplied by x. Now what does this mean? What is this regression equation? Let us try to understand this thing. So if I plot the number of study hours, say 1, 2, 3, 4, 5. So just to make you understand, 1, 2, 3, 4, 5. I mean these are the marks: 50, 40, 30, 20, 10. These are the marks secured by the student out of a 50 marks test, and these are the study hours being put. So in case we plot this relationship and there is a linear relationship, linear, that is, there has to be a straight line depicting the relation between independent and dependent variable. How could the straight line look like? One possibility is that the straight line will look like this, a straight line where x increases and y also increases along with it. Another possibility could be that x increases and y remains constant. So this, you see, this horizontal line shows us that x increases but the marks remain constant. So in both of these cases, we find that there is a linear relationship between independent and dependent variable. Now, before conducting regression, there is one assumption which I spoke about, linearity. So this is meant by linearity, and this assumption has to be fulfilled. If there is no linear relationship, we cannot go ahead with the regression to find out the predicted value of y. So what is this y? Actually, this is the predicted value of y, that is marks secured by the student. We are doing a prediction through regression. A is the intercept, we call it intercept, and B is the slope. B is the slope. Now, what is this intercept? Intercept is the starting value of y when x is 0. So if I say when x was 0 and the marks are 10, so this means intercept in this case is 10. So the line is starting from 10 on the y-axis. That means intercept is 10. What is B? B is how much y increases on increasing 1 unit of x. Listen carefully once again. How much is the increase in marks on increasing 1 unit of x? Say 1 unit is 1 hour of study. So if I say that increasing 1 hour of study increases the student marks by 10, so that means the slope is 10. Or I say that increasing study hour by 1 unit increases the marks by 5. In that case, the slope is 5, right? So now look here carefully. If I say x, these are the study hours, and y, the marks. In x, I plot that 0 hours, then marks is 10. 1 hour, marks is 15. 2 hours, marks is 20. 3 hours, marks is 25. So this is what I need to plot. Now, there is a difference between predicted and actual value which we get, right? Or the observed value, actual or observed. So when we go by this equation, y is equal to alpha plus bx, beta into x. Actually, this is alpha and beta, right? This is alpha, this is beta. So we say that this is the predicted value of y. But what about the actual value? Let me explain to you what is a residual. Then you will come to know what and how do we use this equation. Now you see, residual is equal to actual value minus predicted value calculated from the given sample to us, right? So let us check it out. So let us check it out how it's done. I'll take you a little further. So yes, now here you see that if I talk about the actual value of y would be alpha plus beta into x plus error. This error is the residual. Residual means actual value minus predicted value, right? Actual minus predicted value. So when you want to find out the actual value of y, then you need to add in the error, which is the actual minus predicted value. From this, the concept of confounding variables arises. It means that this regression equation, this one, can never give you perfect actual values because there is always a scope of error which is attributed by confounding variables or unobserved variables in the equation. What do you mean by this? It simply means that the marks of the students in a test are not just affected by study hours, they may be affected by some other things also. They could be the intelligence of a student, they could be the knowledge or understanding of the student about a certain topic. But those variables we have not included in our study. That is why there is a scope of error. And when we find out that the actual value was this and the predicted value got in through this equation is something else, we get the residual. When we add that residual to this equation, we get the actual value. So y here means the actual value which includes the error. I hope I am making the points quite clear to you. Now, let us go ahead to the assumptions of regression. Now, as I told you, there are three important assumptions of regression. Linearity, which I discussed with you right now. Second is endogeneity. Endogeneity means there are certain hidden variables. What are they? How do we find them? What to do with them? What is the remedy for this? How to test it? I'll tell you all about that. And the third is heterogeneity. Heterogeneity means there are different samples in your collected data. I mean, there are different groups of respondents when we talk about social science research. Heterogeneity may arise on the basis of special demographic characteristics or certain other characteristics as well. It could be observed heterogeneity or it could be unobserved heterogeneity. In case the heterogeneity is observed heterogeneity, you know through the theory that in your data set there are two different groups which will behave differently in your study, say based on gender, male and female. Then in that case you conduct a multi-group analysis to showcase your result. That is a remedy of heterogeneity. But first we need to check whether there is heterogeneity in our data, or can we go with the pooled data analysis, complete data analysis. We test it through heterogeneity test, the prediction oriented segmentation, or the FIMIX. There are two tests which are popular: FIMIX, finite mixture, or POS, prediction oriented segmentation, both of which can be easily conducted in smartpls 4 version. Once you get to know there is heterogeneous data, then you can produce your results according to the multi-group analysis. That is how you deal with heterogeneity. In case of endogeneity, which I told you, you can check it through Gaussian copula, Gaussian, Gaussian copula approach, which is quite readily available in smartpls 4 version. Linearity you can check through quadratic effects, QUADRATIC, quadratic effects, which are again available in smartpls 4. Easily you can do all these three testings and then you can deal with how to go ahead with your analysis. Now let us discuss endogeneity a little bit more in detail. Now, when we talk about hidden variables, we talk about covariates. Now, why I am talking about covariates, you will get to know in a little while. Confounding variables, and we talk about control variables. Now, what are covariates? Any independent variable included in your study. Any independent variable included in your study. That is a covariate. Confounding means hidden variable or factor which affects the dependent variable of your study. And confounding is something which affects both the independent variable and the dependent variable in your study. It affects both independent and dependent variable, but covariates affect only the dv. They affect only the dv. So in case you want to say that all confounders are covariates, you are correct. All confounders are covariates. But all covariates are not confounders, because in order to be a confounding factor, a confounder, the covariate has to affect both the independent and the dependent variable, right? Now, what are control variables? So control variables are those variables which need to be controlled in a study so as to check the effect of a newly included variable, independent variable in your study. Say for an instance, the effect of a health supplement on weight gain. So there are health supplements available in the market which help to gain weight for very slim people. So in order to get the effect, the real effect of those health supplements on gaining weight, you will have to first control those variables which affect weight gain. So say for example, fatty food, oily food, no exercise. These are control variables. Control variables like fatty food, heavy food, right? Fatty fats, and then you have no exercise. So these are few of the things which affect weight gain. So if you don't control for these things, you will not be able to realize the actual effect of that health supplement on gaining weight. So we need to control them in our structural equation modeling. There are procedures to control it. In SPSS, you go through hierarchical linear regression, wherein you put the control variables in the covariates block. In the covariates in SPSS, you enter the control variables to control for their effect. Now, let us understand this instrumental variable. What is this instrumental variable? See, we spoke about confounder, and this is a covariate. I told you that covariate affects the dependent variable. This is the independent variable in our example, exercising at the gym. The dependent variable is weight loss. So we are studying about the effect of exercise at a gym on the weight loss. Confounder is something which affects both the independent and dependent variable. So you see, inner motivation of a person, inner motivation in this case acts as confounder, right? So that leads a person to go to the gym, exercise at the gym, and weight loss. How come? Weight loss is not just possible through exercising at the gym. It is also possible through healthy eating habits, right routine of sleeping, and several other factors affect weight loss. But in this study, we are particularly interested at determining the effect of exercise at the gym on the weight loss, right? So in this case, we will have to control the factors. So in this case, we need a instrumental variable which restricts our study to exercising at the gym, as we are not considering the confounder motivation, which is unobserved variable in our study, right? It is unobserved. In case it was observed, then we could have controlled it. Controlled in our study, it becomes a control variable. But here, it's unobserved in our study, so we take an instrumental variable. So in this case, we can take gym membership coupon as an instrumental variable. So those guys who have a gym membership coupon, they have got this membership coupon, they have enrolled at a gym. Now we can say that we are confining our study to only those people who go to the gym and exercise at the gym to study the effect upon weight loss without considering other factors which are responsible for weight loss. In this case, what about this covariate? The covariate metabolism is something which affects weight loss, right? So the metabolism of a person also affects the dependent variable, that is weight loss. So we can control for this covariate and make it a control variable. So in case we have got the values of metabolism of different people, we can add this as a control variable so that we exclusively get the effect of exercising at the gym without considering the effect of metabolism. So this is how you should plan your study. I hope I've tried to explain in very simple terms what do you mean by these different terms, what are the assumptions of regression, what is regression, what are residuals, how to check these three assumptions of regression in advanced softwares. Further, I will be making a video on how to check these effects in smartpls. Till then, you can share this lecture video with all your friends so that they come to understand the basic fundamentals of regression analysis. See you next time with some more informative content. Till then, thanks a lot.